Today we will discuss how to use set theory in solving problems of probability. Actually, set theory, we have one idea where we can think of Venn diagram, that is event A. If I denote in like this, it's a circle, and B is another circle, that is B, as this one. Then we say this is the common part, that is A intersection B. That means this portion is common to both the events A and B. And this portion is A but not B. That means we can denote A B complement, and this portion we can denote B intersection A complement. So altogether these three we denote A union B. Therefore, we are having one clear idea from the Venn diagram that A union B is comprising of total A and total B, but this portion will be taken twice, so we'll delete that portion. So we can use an idea from this diagram. Keeping the diagram there, we have some formulas. P A union B, that means probability of A union B. The idea of probability of A union B is the total chance of the event A and with the probability that B will also happen. That means A or B, we can say either A will happen or B will happen or both will happen. That means three possible cases. So altogether we are finding that A union B means the event A will happen or B will happen. That means at least one of the two events will happen. And we have the formula for this: probability of A, that is this total circle, plus probability of B, that means this total circle. But this portion taken twice, so we'll subtract. This is a very important formula for probability. This we can consider as the addition concept. That is, we add, but the common portion will be deleted. The next formula we are getting from here is P A intersection B complement. That means not the whole portion of A, but the portion of A excluding the B. That means P A not B. We can have the formula P A minus P A intersection B. Then we have another formula P B intersection A complement. That means only B will happen, A will not happen. Here we can have the formula probability of B minus probability of A intersection B. So we are having three type of formulas for P A union B, P A intersection B complement, and B intersection A complement. Another formula we can have from this idea that neither A nor B, that means this portion outside this circle, A complement, B complement. How to find out this probability A complement, B complement? We can use the concept of A complement, B complement probability will be P A complement intersection B complement. That means neither A nor B will be total probability. We have the idea of probability total will be 1. We can say this is probability A union B. So that A complement intersection B complement will be 1 minus P A union B. These are four basic ideas of probability from the Venn diagram. Now we have some concept related to this diagram. Like first concept, if two events are such that we are not getting any common possible cases. No, not this. The diagram will be this A, and the second diagram is not common with B. That means we can say there will be no common possibility that joint occurrence of AB. This A intersection B is not possible with 0. That means A, B are not happening together. This is called mutually exclusive. So when we say mutually exclusive, that two events A, B cannot happen simultaneously, and that means probability of A intersection B is 0. Second concept, if we have the idea that P A union B is becoming the whole, that is 1, that means no other events we are finding other than A or B. This is called A, B are exhaustive. Exhaustive means no more events we can have other than A or B. And the other one is equally likely. That means PA is equal to PB, then it means AB are equal, having equal chance, that is AB are equally likely. These three ideas are very important. Now another important concept we have, that is the conditional idea, the conditional event. Conditional, the concept of condition. We are not interested about this diagram, but we are interested in the idea that probability of A, B by A, that means the event B will happen only when A has already happened. That means what we can understand, that conditional probability of B, that means B is happening, is conditional on A. That means if A happens, then only B happens. So what we can see, that this diagram, if I consider this is A and this is B, then we can understand that B by A means the portion of B including A. How much portion of B included in A? That means total A portion is this. That portion, how much is including B? So we can say the concept of formula of B by A will be total A is this much, but this portion is common with B. So A, B, this common portion will be the numerator and denominator will be the whole of A. So this is a very common idea, simple idea of conditional event, that A is a possible event. A cannot be 0. Probability of A cannot be 0. It should be a positive number, but then B by A can be found out. But if I say A by B, A by B will be A intersection B, that means A, B both, but how much portion of B includes A? That means B including A. So the diagram is now we are now thinking from this side. A by B is out of B, how much is A? And B by A is out of A, how much is including B? So what you're finding, A is denominator, so PA will be the denominator. And B is here, the not conditional point, then we write PA intersection B by PB. Technically saying, it is not A by B or B by A, it should be B slash A. That means B on the assumption of A already happened, and this should be A on the assumption of B. So these are the ideas of probability we can have concept. And the next idea of the probability, that A, B are not conditional, but they are both jointly happening. We say independent event. This word independent is very important. Independent events means A and B, two events, A intersection B, A and B, A intersection B means probability of A then into probability of B. That means A will happen and B will happen, but both will happen without depending on the occurrence of the other. Here we don't write B by A or A by B, we write just A intersection B is PA into PB. Now we can take an example. Like this example is, first example we can take, that PA is equal to given. PA is equal to, is a value given 2 by 3. PB is equal to, this is an example we are solving now, 3 by 5. And PA union B is, this is given, all values are given, 5 by 6. And the question is, first question, find first question, find PA by B. Second question, PA by B complement. And the third question, PA complement by B complement. So these three questions we will solve. So in order to do the first question, we need A intersection B, because if I look at the concept just now we have discussed, this will be PA intersection B divided by PB. We don't have the idea of PA intersection B in the question, but we have the idea of A union B. So we can use the concept. First problem, we can use the concept of A intersection B taken from the idea of A union B. Formula is PA union B is PA plus PB minus PA intersection B. This is the formula generally we know. This is 5 by 6, then this is 2 by 3, this is 3 by 5, and this is PA intersection B. So all we need to solve this algebraically, to get PA intersection B. And we are getting PA intersection B by solving, this is 10 plus 9, that is 19 by 15, 19 by 15 minus 5 by 6. So ultimately when we are simplifying, it is becoming 13 by 30. the LCM I have taken 30, the LCM of the two. So it becomes 38 and this becomes 25. So 38 minus 25 is 13 divided by 30. So this is A intersection B. Now come to the formula. This one, PA intersection B, A by B we are now solving. This is 13 by 30 and divided by PB, probability of B. Probability of B is your given as 3 by 5. Probability of B is 3 by 5. So it will be reciprocal value is 13 by 30 into 5 by 3. So it is 13 by 18. So this is the first answer. A by B is 13 by 18. Now the next question is P A by B. Another one we have discussed, that is A by B complement. The second one, A by B complement. Second question was probability of A B complement. So what you will have? A intersection B complement. Why? Because A inside B complement is A intersection B complement and the denominator will be B complement. So we have the idea of A intersection B complement from the diagram. This is the diagram. A intersection B complement. That means this portion. And that portion is total A minus A intersection B. Total probability of A minus probability of A intersection B. And denominator is B complement. It is 1 minus PB. So all you need now, PA we know, PA probability of A is 2 by 3 minus 13 by 30 divided by 1 minus 3 by 5. So ultimately we solve, and that is 7 by 30 divided by 7 by 5, and ultimately when we solve, that is becoming not 7 by 5, this will become 2 by 5, so it will be 20 minus 13 divided by 30 and into, this is 2 by 5, so 5 by 2, so final answer is 7 by 12. So this is the idea to solve the problems like this. And the last question of this problem was A complement by B complement. In these problems all we are requiring is nothing but to use the algebraic concept of probability. This is A complement, B complement both, because A by B is B intersection by B, but here it is B complement. So how you solve? It is A complement intersection B complement. We have the idea that 1 minus A union B. This is 1 minus A union B divided by 1 minus probability of B. A union B we have the value, that is 5 by 6, and B we know, that is 3 by 5. So ultimately your answer is 1 by 6 in the numerator and denominator is 2 by 5, that means 5 by 2. So your answer is 5 by 12. So this is the idea of how to solve problems of this kind. It is a conditional concept. But if I take a problem like this, the PA, another one I am taking PA, another problem I am taking PA, probability of A is your 1 by 4, it is given. And PB, another value of another event is PB, probability of B, and the probability is 1 by 3. Then they are asking first question, they are asking PA union B. First point, A, B are mutually exclusive. And second one is A, B are independent. So two questions we will solve. First question, the idea is A, B are mutually exclusive, and second question, the one idea is the A, B are independent. So how to solve the first one? First one, A, B are mutually exclusive. So idea is PA intersection B is 0. So our formula PA union B will become PA plus PB minus 0, because no intersection is required. A is 1 by 4, B is 1 by 3, answer is 7 by 12. The second part is independent event. That means A, B are such events that A intersection B will become PA into PB. In this case, PA intersection union B will be PA plus PB minus PA into PB, because already we have seen that independent result will be like this. Then 1 by 4 plus 1 by 3 minus 1 by 4 into 1 by 3, it is 6 by 12, that is half. So these type of problems we can solve using the idea of the set theory when the questions are formed like this. So this is all about how to solve probabilities using some concept of set.